Hi, hello there. Welcome to Design Lifecycle. On this video lecture, we are going to cover business-driven network. Next would be the PBM network lifecycle approach or the plan, build, and manage approach. And what are the project deliverables? Let's get started. Business-driven network. So designing a network can be compared to designing a building. So before designing a building, an architect has to consider many factors, like how will the building be used? Would it be for commercial or residential? What are the needs of the people using this building? So basically, in a building, we need electricity, we need water supply, telecommunications, and others. Are there any special requirement? Well, if it is a building, we have to consider the organization. Okay? So similarly, a network engineer has to consider factors such as which business functions the network will support. If we are going to consider, for instance, a university, so we have to consider having a learning management system or LMS. The enrollment system might be running over the infrastructure, payment, and other services. The various types of users who will access the network. Again, if it is in a university setup, we have to consider the students, the faculty, personnel, and guests who might be using the network, and how the network will affect by future growth. So we have to consider the number of users in the future. The growth of user means we need a higher bandwidth to consider on the network infrastructure. So business-driven network is a network design leaning towards the organization's business objectives. As a network architect, you have to rely on business needs when choosing the best technologies and design patterns for your network. You have to consider how the technology that you will choose will affect the business in the future. If you want to build a network that serves as a business enabler, not a cost center, you must gather accurate business requirements and information from the customer. So first, we need to understand the company. A good way to start gathering information is to understand the company. So here are the few questions that you could ask. Okay, so that you might want to start with. First, you have to ask, how big is the network? Is it a LAN? Is it a WAN? Will it cover a geographical network? Will it connect network from different cities, different country? Okay, so you have to know that. You have to know the size of the network. Also, how many users are connected? Okay, how many devices per user will be considered? And where are the users located? So all of this should be gathered before designing a network. And all of this should be considered before designing a network. Next is we have to know the end users. So who are the end users of the network infrastructure? So when you think about the users, who will access the network? You have to consider internal, external, and guest users. You must also understand the endpoints as well as the people. So here are some of the few questions that you could ask. So are the endpoints static or mobile? So we're talking about the computers or the workstations. Okay, so is it fixed? Or are we going to consider mobility? Okay, which computing environments are the users accustomed to? Are the users willing to adapt to changes? So this has been a challenge for a network engineers and network managers. Do the users travel a lot? So we are thinking of the mobility of the users. So there might be some roaming users in the organization. So which types of communications are used within the company and which are used for external partners. Next is you have to consider the technological aspects of the company, okay, so which are another major influence on the network design. So here are some of the questions that you could ask or you should explore. So which applications are in use at the company? Are there any existing problems with any of the applications that is being used? Or how many data or how much data does the network produce? Okay, so are there any special requirements regarding the data path? So again, in considering the business-driven network, we have to consider all of these components here. You have to know the company overview. You have to know the goals, competitors, changes in the market. You also have to know the company's network. Okay, so the current operations of the network, including the size, the number of users, number of devices, the applications being used on the network. Okay, so the problems encountered in the network, all of those should be considered in network design. Also, you have to know your users. So internal users, external users, guests, endpoints, and people should be considered on the network design. And when designing a network, we should not design a network based on today's needs. You have to consider at all cost, okay, so the future expansion of the network. PBM Network Lifecycle Approach. PBM stands for Plan, Build, and Manage. This is one of the Cisco's life cycle model, which was created as a simplified way to engage customers on their projects. So the PPDIOO, or the Prepare, Plan, Design, Implement, Operate, and Optimize phases are still relevant, but they map to 3 simple phases. So it has been simplified with Plan, Build, and Manage, or PBM. So this is easier for customer engagement. So different teams, companies, or consultants can even handle different sections of the project. For example, consultant A is designing the solution. So this is the plan section. Internal IT is implementing the solution. So that is a build section. Okay? And a managed services team operates the solution. So that is a managed section. Okay, so the PBM network lifecycle approach reflects the lifecycle phases of the standard network. So the model consists of 3 phases, as mentioned earlier. Okay, so the plan, build, and manage. Let's focus on the plan. Okay, so the plan section includes strategy and analysis, assessment of the current network. You have to know the current situation, the current operations of the organization, including the current setup, and designing of the revised network. So under planning, strong planning is critical in order to deliver the specific outcomes that you need. The plan phase involves setting expectations correctly, developing an architectural strategy, building the transformational roadmap and design, and defining a plan for tracking results and impacts. So the next one is build. So the build section employs deployment of the network or new network design, migration of the new network, and validation of the new network. So with build, after you design the network and after the design has been approved, the implementation of the network begins. So the network is built or extra components are incorporated according to the design specification. The goal is to integrate devices into different network components, or shall we say the existing network, with a minimal disruption. So after the deployment, you will perform a series of operational tests to validate the design. That is under the build phase. So the last one would be the manage phase. Okay, so the manage section includes product support, solution, optimization, and operations management. So once your network is built, you must maintain an operational excellence and efficiency. Maintenance involves proactive management of the network so that you can identify and resolve issues before they affect the organization. So maintenance also involves fine-tuning your infrastructure and applications on an ongoing basis to maximize the network performance. Now let's get into the details of each of these phases here. So the first step was planning. Okay, so strategy and analysis, identifying the company business requirements and technology strategy. So the first step of the plan phase is to identify the company business requirements and the technology strategy. So you must review the current business conditions and make sure that the new requirements and technologies fit into the existing state. So strategic analysis is a process that involves researching an organization's business environment within which it operates. You also have strategic analysis, okay, so which is essential to formulate strategic planning for decision making and smooth working of that organization. So the next one is assessment. So the next step is to assess the current state and, if necessary, help project managers to create a project plan. So the need for a project plan depends on whether there is an existing network. So if there is an existing network, you will have to audit the existing infrastructure and operational environment. Now, auditing ensures that the changes you make will not adversely impact the network usability, helping you avoid costly delays. So assessment means assessing the current state of the organization. The third step in the plan phase is to develop or update a comprehensive network design. So the design should meet all the business requirements that were gathered in the strategy and analysis phases. So design includes developing or upgrading a comprehensive network design. Let's get into the details of the build phase. Let's start with the validation process. The validation process helps you to confirm that the solution meets customers' requirements. The deployment process helps you to successfully deploy new network solutions. And the migration process accelerates new deployments and helps you to control costs, improve operational excellence, and mitigate risks when refreshing your network. So with a build phase, you can use many different implementation methods. So regardless of which method that you choose, it is always good to set up a test environment that you will use to simulate different network designs. So using test environment gives you the ability to find any potential problems which can be resolved before the real implementation. So once you have tested the network design, the real implementation can take place. So depending on the size of the implementation, you may run into some logistical problems like deployment, configuration, testing, and so on. So after the network is built, you should run a series of verification tests to confirm that the network is operating as expected. So if there is a problem, you should fix it as soon as possible. One of the quickest ways to fix an operational issue is to roll the network back to a working state. Next would be the manage phase. So the product support process offers automated network equipment inventory management. Next would be the solution support process, which provides priority access to dedicated resources to manage and troubleshoot issues within the network. Next would be optimization process. The optimization process helps you optimize your network, infrastructure, and applications. And operational management processes. The operations management process simplifies network and IT operation with proactive monitoring and management of your network. So during this phase, the company manages the network, which includes proactive and reactive monitoring, as well as security management. So minor moves, adds, or changes can occur during this phase as part of the optimization of the network. So optimization is normally the result of a change in business or technical requirements. Now, if we are going to map the PBM with the PPDIOO, as shown here below, each section still maps to PPDIOO. The teams in each PBM phase can refer to their relevant PDIOO tasks. Like for planning, so that includes preparation, plan, and design. Okay, you've got the PPD there. And then for build, you've got implementation and deployment. Okay, for manage, you've got optimize and operate. Project deliverables. You should document every stage of the network design process. So the following are some of the most common documents. You've got the HLD, or the high-level design documents. This includes the bill of materials, or the BOM. Also, you've got the LLD, or the low-level design document, which includes the network migration plan. You also have the NIP, or the network implementation plan, and the NRFU, or the network ready for use test plan. Let's get into the details of each of these deliverables. High-level design. The HLD is an overview of the entire network solution. So one of the most important part of the HLD is the bill of materials. So it provides the business and technical requirements of the design, details the new services that can be provided, and gives an architectural overview. So as mentioned here, one of the most important part of the HLD is the bill of materials. BOM is a comprehensive inventory of raw materials, assemblies, sub-assemblies, parts and components, as well as quantities of each needed to manufacture a product. In a nutshell, it is the complete list of all the items that are required to build a network. So the HLD serves as a reference for both the designer and the organization or the company. LLD, or low-level design. The basis for the LLD is the HLD, which is updated with all the intricate details required to successfully deploy the design. So it includes network topology and hardware platforms, hardware and software protocols and functions, addressing and routing strategy, scalability and redundancy, security considerations, VLANs, and so on. So if there is a migration plan, the NMP is also part of the LLD. So NMP, or the network migration plan, is a base requirement for successful migration plan is that of shared responsibilities between the network team, core engineering team, and the service delivery function to arrive at a collective decision on inventory, customer expectations, and network requirements. So doing so arrests snags caused due to inventory mismatches, readiness to make alterations to the network, meeting customer expectations, and inventory management. So they typically lead to post-migration hiccups like service outage issues, unmet requests for upgrade and downgrade, missing deadlines set by the customers, and lack of service assurance support to the customer. So if these issues persists, the account teams are disabled from staying updated on the status of their customers on the network. So for example, the number of active services, bandwidth of services, and whether or not the collections teams is lockstep with services provided. Migration plan testing. So one of the most challenging and critical aspects of networking project is the migration of users and services to a new network infrastructure. So even the best network designs are destined for failures if they cannot be implemented without causing extended service outages. Yet, despite the risks, many network architects spend a disproportionate amount of time focused on the end state of their network designs, developing migration plans as an afterthought, if at all. So a good migration plan should address how routing protocols and applications will interact with a network that is partially migrated. So providing success indicators and backout plan when unexpected behavior is encountered during the migration. So testing of a migration plan is an essential part of the design process for networking projects of any scale. So it is sometimes a requirement for the implementation or operation groups responsible for making changes to the network. So in some instances, a migration plan can be developed during a design verification lab test effort by repeating the baseline and performance test on the interim topology consisting of the old and the new network. So a high-level migration plan tests the network backbone that might look like this. Okay, so we have several steps. Actually, we have 8 here. Okay, so the first one would be build a prototype of the old and the new network backbone topologies. Second, you have to run a baseline test using known traffic patterns from the existing and new networks. Third, physically and logically interconnect the old and the new network backbone topologies, as they will be connected during the migration. If this will take multiple steps, each interim topology should be tested. Fourth, run the same set of baseline tests on the interim network that you run on the old network. You also have to simulate device and circuit failure scenarios in each interim step of the migration in order to understand the impact on test traffic and whether any collateral damage occurs. Sixth would be disconnect the old portion of the network or reprovision it on the new backbone. So this should be done the same way as the migration plan will be done. So if this will be done in multiple steps in your plan, then you should test each one of them. Seventh, repeat the set of baseline tests. And last one would be run a set of new tests that exercise any new features or services to be offered by the new network. So a migration test would be considered to be successful when the baseline test results meet or exceeded the performance of the old network and the features offered by the new network are verified. NIP, or the Network Implementation Plan. So the Network Implementation Plan service provides you with expert project planners who review the high-level design and detailed design and prepare a network implementation plan document that will implement the plan change in most efficient manner with a minimum disruption to your existing services. So the designated consultants will provide guidance, okay, on synchronizing the plan deliverables into your existing project plan in case this network change is part of a wider project rollout. So leveraging experts from the team will minimize your risk and ensuring quality deployment with a faster turn-up of the new infrastructure elements. Network implementation plan review is also necessary. So having an expert review any existing network implementation plan document will definitely help identify any gaps or risks that may have not been highlighted. So the network implementation plan review service provides this additional level of diligence needed to ensure project tasks are optimally planned and deliver on the promise with minimum risks. So after the implementation plan review, the network design validation and testing is also a good practice. So the goal is to identify any interoperability issues faster and with proven testing processes before sending the equipment to the field sites. So you have to do it remotely or on-site. So the network design validation and testing service leverage the network implementation plan to build, configure, and test system at any location. Okay? So based on the document test plans and laboratory topologies, because you have to simulate it before you implement it. That's a good practice in network design. Okay? So the team performs intensive system-wide and subsystem testing to proactively identify and make design modifications if needed. So this team will generate a test report, okay, documenting the findings. And then the organization can benefit immensely from this service that will enable a plug-and-play installation at the field sites based on the detailed system integration, testing documentation provided. So proven best practices shows that having issues identified saves customers time and money when it comes to getting your network solution online. NRFU, or Network Ready for Use Test Plan. So a Network Ready for Use, or the NRFU, on a new greenfield network infrastructure as a last step in certifying that it is ready to carry production traffic. Okay? So during the NRFU test, network devices are methodically checked to ensure that they have been implemented according to the design specifications and are running in an error-free state. So some of the tests that are commonly associated with the NRFU includes device tests, hardware, software, inventory, power, syslog error, okay, circuit tests like throughput, delay, jitter, errors, if there are errors. You also have to perform some sort of routing tests, adjacencies, routing table consistency, okay, traffic tests, end-to-end traffic testing, the network service tests like the multicast, the quality of service, WAN acceleration, okay. You also have to perform application testing, management, network management software, and security tests. In some cases, the NRFU testing extends to a limited production pilot where a low-risk site or portion of the network is cut over to the new network and monitored closely for a probationary period of time. All right. So that's the end of this video lecture. See you on the next video.